Next is question number 49, which says that let a complex number z satisfies the equations mod z plus 3 minus 3 iota equal to 1. Similarly, two more equations are given where iota is obviously under root of minus 1. Then we have to find the solution of z. Now here it can be seen that these two are a little easier equations. So let us try to solve it. Let us say z is equal to x plus iota y. So from third equation we will get x square plus y square equal to 25, right? Now from first equation we get x plus 3 whole square plus y minus 3 whole square is equal to 1. So we will get x square plus y square plus 6x minus 6y plus 9 minus 1, that is plus 17 equal to 0. Now we know that value of x square plus y square is directly 25. So putting it directly 25, we will get 6x minus 6y plus 25 plus 17, that is plus 42 equal to 0. That is, we can say that x minus y plus 7 equal to 0. So let us put this here to get the value of x and y. We will get x equal to y minus 7. So we will get y minus 7 whole square plus y square equal to 25. That is, we can say that 2y square minus 14y plus 49 minus 25, that will be plus 24 equal to 0. That is, y square minus 7y plus 12 equal to 0. So we will say that the roots will be y minus 3 into y minus 4 is equal to 0. That is, either y is equal to 3 or y is equal to 4. Now from equation 1 we can say that the value of x will be equal to, for y equal to 3, x will be equal to minus 7 plus 3, that is minus 4, and for y equal to 4, value of x will be equal to minus 3. So we have two distinct values of z, that is minus 4 plus 3 iota, or we have minus 3 plus 4 iota. These are the two values of z. Now it have to satisfy the second equation also. So let us substitute the value of z in the second equation to find whether it satisfies it or not. So let us firstly put the value of z equal to minus 3 plus 4 iota. Left hand side we have mod of minus 3 plus 4 iota whole square plus 6z, that is minus 18 plus 24 iota minus 6 minus 24 iota minus 8 iota into z, that is minus 3 plus 4 iota. Its modulus. Further it is equal to modulus of 9 minus 16 minus 24 iota, that is cancelled with this one, minus 18 minus 6, that is minus 24 minus 24 iota plus 24 iota minus 32 into iota square, that is plus 32. So these two will also get cancelled. So this will be equal to 9 minus 16, that is minus 7, minus 24, that is minus 31, plus 32 modulus, that is 1. On the right hand side also we have 1. So it can be seen that value of z equal to minus 3 plus 4 iota satisfies all the three equations. Similarly, it can be seen that if you put z equal to minus 4 plus 3 iota in the second equation, it will not satisfy it. So we have only one solution, that is z equal to minus 3 plus 4 iota. Now let's check the options. Option number 1 says that it lies in second quadrant, which is true. So option number A is correct. Option number B is not correct. C is also not correct, and D is correct. Therefore, A and D will be the answer of this question. Next is question number 50, which says that if x is equal to p by q into pi, where p and q are natural numbers co-prime to each other, is a solution of the equation 2 minus cos square x minus sin x whole raised to the power 1 minus sin square x minus cos x equal to 1, where x is going from 0 to 3 pi minus pi. Right. Firstly, let's find the solution of this equation, writing 1 minus cos square x equal to sin square x. So, we will get sin square x minus sin x plus 1, and in the power we have 1 minus sin square x, writing it as cos square x minus cos x equal to 1. So we have to find the solution of this equation. Now let's make different cases here. Case 1, that is sin square x minus sin x plus 1, either it is equal to 1, or case 2, that is the power, that is cos square x minus cos x, power should be equal to 0. These two are the only solutions. Now solving this further, we will get either sin x is equal to 0 or sin x is equal to 1. And from here we get either cos x is equal to 0 or cos x is equal to 1. These are the solutions. So from all, we will get the solutions in between 0 to 3 pi as x equal to pi by 2. Pi is not in the domain. Further, we have 3 pi by 2, 2 pi, or 5 pi by 2. Further, 3 pi is not in the domain. So these are the solutions of x that we get from here. Now, it have been written in the form p by q into pi. Now, let us find the probability that p plus q is prime. Now, in this case, p plus q is 3. In this case, p plus q is 5. In this case, it is 3. And in this case, it is 7. So, all of them are prime, which means that its probability is 1. So, option number A is correct answer. Next, option number B is incorrect. Now, probability that q minus p is positive. Let's find the value of q minus p. Here, in the first one, it is 1. In the second one, it is minus 1. In the third one, it is minus 1. And the last one, it is 2 minus 5. That is again minus 3. So, the probability that it is positive is 1 by 4. But here it have been given 3 by 4. So, this is incorrect. Next, the probability that mod of p minus q is prime. Now, the value of mod of p minus q from all is 1, 1, 1 and 3. So, the probability that it is prime is, as we know that 1 is neither prime nor composite. So, the probability of being prime is 1 by 4. So, option number D is also correct. So, we can say that option number A and D are the only correct answer. Next is question number 51, which says that consider a function gx equal to integral from 0 to x ft dt, where x is going from 1 to 4, where fx is equal to greatest integer x plus modulus of x minus 2. Then we have to find the points of discontinuity of gx and so on. So let us go option by option. Let us firstly discuss option number A, in which we have to find the number of points of discontinuity of gx. Now gx is integration of fx, so gx will be discontinuous only at those points where fx is not defined. As fx is defined everywhere, so gx is continuous everywhere. So option number A is correct. Now, next it says that number of points of non-differentiability of gx. Right. Now, to find the points of non-differentiability of gx, we have to find just the number of points where fx is discontinuous. Only those points will be non-differentiable for gx, where fx will be discontinuous at x equal to 2 and x equal to 3, right? So the number of points will be 2. So option number B is also correct. Now option number C says that there is exactly 1 point of inflection for gx in its domain. Now to find the number of points of inflection, we will find the number of points where the second derivative changes sign, or we can say that the monotonicity of the first derivative should change, right? Now we can see for fx at x equal to 2 minus fx will be equal to 1 plus 2 minus x, that is 3 minus x, and at x equal to 2 plus we will see fx is equal to 2 plus x minus 2. So this is equal to x. So here we can see that slope of this is negative and slope of this one is positive. So the monotonicity is changing. So we can say that it is a point of inflection, and it can be seen that only 2 is a point of inflection. So number of points is 1. So option number C is also correct. Now option number D says that Gx has at least one point of local extremum. Now to find the point of local extremum, we have to find number of points where first derivative changes sign. That is the number of points where fx will change sign. Now it can be seen that for x going from 1 to 4, greatest integer of x is always positive and modulus of x minus 2 is always positive. So fx is always greater than 0, which means that it will not change sign. So it have 0 point of local extremum. So the answer of this question will be A, B and C. Next, let's discuss question number 52 now. It says that consider a function fx equal to sin x raised to the power 4 plus 3 sin square x plus 1 upon sin x plus sin cube x. Now we have to find the type of function it is, and we have to find the number of solutions. Now fx can be written equal to, this can be written as 1 plus sin square x whole square plus sin square x. And in the denominator we have, taking sin x common, we will write 1 plus sin square x. So this is equal to 1 plus sin square x upon sin x plus sin x upon 1 plus sin square x. That is, we can write it as sin x plus cosecant x plus 1 upon sin x plus cosecant x. Let us assume sin x plus cosecant x equal to t. So this is t plus 1 by t. So this is equal to t plus 1 by t. Now as it is given that x is going from 0 to pi by 2, which means that the quantities are positive, so we will say that t is greater than equal to 2. Now let us assume a function ft equal to t plus 1 by t. Let's differentiate it. So we will get f dash t equal to 1 minus 1 by t square. So let us check where the function is increasing and where it is decreasing. So let us put it greater than 0. So we will get t square minus 1 greater than 0. That is, for t going from minus infinity to minus 1 union 1 to infinity, it will be increasing. Now we have t always greater than equal to 2, which means that it will always be an increasing function. Now ft is an increasing function. Also we know that sin x plus cosecant x, it is a decreasing function, as it is given that x is going from 0 to pi by 2. Now if we talk about f of gx, where gx is decreasing function and fx is increasing function, then we know that f of gx will always be decreasing function. So we can say that this fx here is decreasing function. So let us find the maximum and minimum value of the function. Now as x is going from 0 to pi by 2, so let us put x equal to pi by 2. So we will get f pi by 2 equal to 2 plus 1 by 2, that is equal to 5 by 2. So this is the minimum value of fx, that is, it is going from 5 by 2 to infinity, and it is a decreasing function. Now we know that it is a decreasing function, so it is a 1 function, right? So option A is correct. Also, to find the number of solutions of fx equal to 2, we have 0 number of solutions, and number of solutions of fx equal to 15 will be 1. So correct answer will be A and D option. Let's now discuss question number 53, which says that if length of tangent through a variable point P, that is x comma y, on the curve y equal to fx is always equal to the distance of point P from the origin, then the curve can be. A very simple question from application of derivatives. So let us solve it. We know the formula for length of tangent, that is mod y into under root of 1 plus dx upon dy whole square. This is equal to distance of the point P, that is x comma y, from the origin. Its distance will be under root of x square plus y square. So taking square on both sides, we will get y square into 1 plus dx by dy whole square is equal to x square plus y square. Now y square will get cancelled, so we get y square into dx by dy whole square equal to x square. That is dx upon x is equal to dy upon y with plus minus sign. Now if we take integral of it on both sides, we will get ln x equal to plus minus ln y plus constant c. That is ln x minus plus ln y is equal to constant. So we have two solutions from here, that is xy equal to k1 or x upon y equal to k2. So these are the two solutions. So we can say that the curve can either be straight line or it can be a rectangular hyperbola. So from the given options, we can see that A and D will be the correct answer. That is A and D will be the answer of this question number 53. Next is question number 54, which says that consider a bijective function f going from a to r, where r is the set of real numbers defined as fx equal to x minus 2 pi whole cube plus sin x. Then we have to find the range of a and we have to find the integral given. So let us go option by option. Firstly, let's find the value of f dash f inverse x. For that, let us assume the value of f inverse x equal to t, that is x is equal to f of t, that is dx by dt is equal to f dash t. So we can write dt upon dx equal to 1 upon f dash t. So substituting back the value of t, we will get differentiation of f inverse x upon dx is equal to 1 upon f dash f inverse x. Now in C option we have to find its integral. So this will be equal to integral of d by dx of f inverse x from minus pi cube to pi cube. Now its integral will definitely be equal to f inverse x from minus pi cube to pi cube. That is, it will be equal to f inverse pi cube minus f inverse minus pi cube. So this will be equal to, now it means that the value of this is equal to pi cube. Putting it equal to pi cube, we will see that the value of x will be equal to 3 pi, right? So its value will be 3 pi minus. Now when we put it equal to minus pi cube, then we will get x equal to pi. So it is pi. So the integral will be equal to 2 pi. So we can see that option number C is the correct answer. Now this is quite obvious that the range of the function will be minus infinity to infinity. So A given in option A is correct. So option number A is also correct. Now let's find point of inflection. Now we know that point of inflection, double derivative should change sign. So let us put double derivative equal to 0. So the value of f dash x will be equal to 3 times x minus 2 pi whole square plus cos x, and the value of f double dash x will be equal to 6 times x minus 2 pi minus sin x. So let us put it equal to 0. Now if I put it equal to 0, then we can see that the only solution will be x equal to 2 pi. This will be the only solution, which means that x equal to 2 pi is the only point of inflection. So option number D is also correct. So answer of this question will be A, C and D. Let's now discuss question number 55, which says that if A, B, C and D are 4 points in three-dimensional space such that A, B, C, D vectors are given to us, let L be the shortest distance between the lines A, B and C, D, then which of the following is or are correct? Let us draw the lines A, B and C, D. Let this be A, B. So the point here is A, that is 2, 1, 0, and the point B on it, that is 1, 1 and minus 2, and next point C, that is 1, 1, 1, and next point is D, that is 1, 3, minus 1. So a very simple and sweet question. We know the formula of shortest distance, let us say SD. It will be equal to modulus of AC vector. We will take the scalar triple product of AC vector. Let us say eta 1 vector is representing the direction ratio of the line AB and eta 2 vector is representing the direction ratio of the line CD. So AC vector, eta 1 vector, eta 2 vector divided by modulus of n1 vector cross n2 vector. We have to take the modulus of this as a whole, so that will be the shortest distance, right? So that will be equal to, now directly writing in the form of scalar triple product, we have AC vector as minus 1, 0, 1. Eta 1 vector will be B vector minus A vector. That will be minus 1, 0, minus 2, and eta 2 vector, that is D minus C vector. So it will be 0, 2, minus 2. So we have to take the determinant of this, that will be equal to, let us take it along 2. Minus 2 into 2 plus 1. So that is equal to minus 2 into 3, that is minus 6. So we are taking its modulus. So that will be equal to 6 upon eta 1 cross eta 2. That is, now we have to take cross product of minus 1, 0, minus 2 and 0, 2, minus 2. So that will be I cap into 4 plus j cap into minus 2 plus k cap into minus 2. So its modulus will be under root of 16 plus 4 plus 4, that is equal to under root 24. That is 2 times root 6, that is equal to root 6 upon 2, that is equal to root of 3 upon 2. That is given in option number B. So we can say that option number B is correct. Now AB and CD are skew lines, because if they have been intersecting, then shortest distance would be equal to 0, but it is not. Also the lines are non-parallel, so definitely the lines are skew lines. So option number C is also correct. And in option number D, the formula have been written which we had just applied. So we can say that option number D is also correct. So answer of this question will be B, C and D. Next, let's take up question number 56, which says that a box contains 4 white and 2 red balls. Let X be the number of red balls drawn in a random draw of 3 balls. Then we have to find the mean and variance. Let us say we pick 0 red ball, or we pick 1 red ball, or we pick 2 red balls. That is, the value of XI is either 0, 1 or 2. So we have to find its probability. Now we have 4 white and 2 red balls, which means that if I draw 0 red balls, then I will have 3 white balls. If I have 1 red, then I will have 2 white. If I have 2 red, then I will have 1 white ball. So let us find its probability. Its probability will be, we have to draw 0 red ball from 2 red balls, that is 2C0 into 4C3 divided by 6C3, and here we will have 4C2 into 2C1 upon 6C3, and here we will have 2C2 into 4C1 upon 6C3. Now we have to find the value of mean, that is equal to summation xi into pi, that is equal to 0 plus 1 into 4C2 into 2C1 upon 6C3 plus 2 into 2C2, that is 1 into 4 upon 6C3. So that is equal to 4C2 is 6, that is 6 into 2, that is 12 plus 8, that is 20 upon 6C3, that is also 20. So mean is equal to 1. So option number 1 is correct. Also we have to find the variance, that will be equal to summation xi square into pi minus mu square, where mu is mean. So this will be equal to 0 plus 1 into 4C2 into 2C1, that is 12 upon 20 plus 4 times 4 upon 6C3 minus mu square, that is 1. So this is equal to 16 plus 12, that is 28 upon 20 minus 1, that is 8 upon 20. So that is equal to 2 upon 5. So option number D is also correct. So answer of this question will be A, D. Next is question number 57, which says that a transverse common tangents to the circles S1 and S2 touch the circle S1 and S2 at AB and A dash B dash, and the common tangents intersect at the point P. Then we have to find the coordinates of P and we have to find the slope of the transverse common tangents. Also we have to find the area of quadrilateral. So let us solve the question. The question is quite lengthy, so let's go for it. Let us say these are the lines going through the center of the circle. Let us say O dash and O. So let us join these lines, and it have been given that these points are A, B, A dash and B dash, right? Now O is 0, 0 and O dash is 5, 0, and they are intersecting at point P. Now radius OA is given to be equal to 2 and OA dash is given to be equal to 1, right? Now this is what have been given to us. Here it can be seen that triangle OAP is congruent to triangle O dash A dash P. So we will say that OA upon O dash A dash, that is 2 by 1, is equal to OP upon O dash P. That is P is dividing O dash in the ratio 2:1. So the coordinate of P can easily be found, that is 10 plus 0 upon 3, that is 10 by 3, 0. So these are the coordinates of point P, which is not given in option A. So it is incorrect. Now let us say this angle is alpha and this angle is theta, and let us draw perpendicular from A on line OP. Let this be M. Similarly, let us draw perpendicular from A dash also. Let this point be N. So if this is alpha, then this angle will also be alpha. Now we know the length of OP, that is 10 by 3, and we know OA is 2. So we can say that in triangle OAP, sine alpha will be equal to 2 upon 10 by 3, that is 3 upon 5. So we can say that cos alpha will be equal to 4 by 5 and tan alpha will be equal to 3 by 4. Now we have this value, so we can find the value of AP also. Now AP will be equal to under root of OP square, that is 100 upon 9 minus 2 whole square, that is 4. So that will be equal to 8 upon 3. This is the value of AP. So we can find the value of AM from here. See why we are doing it? We have to find the area of quadrilateral formed by AB, A dash, B dash. So let us firstly find the area of quadrilateral AMN, A dash, and then we will double it. Now to find the area of this trapezium, we have to find the value of AM and MP and PN and A dash N, right? So let us find the value of AM now. In triangle AMP, we can say that sine alpha, that is 3 by 5, is equal to AM upon 8 by 3. So the value of AM will be equal to 8 by 5. Value of AM is 8 by 5. Now let's find value of MP. So tan alpha, that is 3 by 4, is equal to 8 by 5 upon MP. Now the value of MP will be equal to 32 upon 15, right? So the value of MP is 32 upon 15. Similarly, we will find the value of Pn and A dash n. So let us say this angle is theta. So this angle will also be theta. Now we have this is 1 and value of PO dash will be equal to 5 minus 10 by 3, that is 5 by 3. This is the value of PO dash. So in triangle PA dash O dash, value of sine theta will be equal to 1 upon PO dash, that is 5 by 3. So this is equal to 3 by 5. So from here we can say that cos theta will be 4 by 5 and tan theta will be 3 by 4. So further, let's find the value of A dash P. A dash P will be equal to under root of PO dash whole square, that is 25 upon 9 minus 1, right? So that is under root of 16 upon 9, that is 4 upon 3, right? So this is the value of A dash P, that is 4 upon 3. So in triangle A dash PN, let's apply sine theta, that is 3 by 5 will be equal to A dash N upon 4 by 3. So the value of A dash N will be equal to 4 by 5, right? So its value is 4 by 5. Now let's find the value of Pn, that is tan theta will be equal to 3 by 4 equal to 4 by 5 upon Pn. So the value of Pn will be equal to 4 by 5 into 4 by 3, that is 16 upon 15. This is the value of Pn, 16 upon 15. So we can find the area of quadrilateral AB, A dash, B dash equal to 2 times area of the trapezium A dash, NM. So that will be equal to half into sum of parallel sides, that is 8 by 5 plus 4 by 5, that is 12 by 5 into distance between them, that is MN, that is 32 by 15 plus 16 by 15, that is 48 upon 15. Cancelling by 3, we will get 5, 4 and we will get 192 upon 25 square units. So option number D is correct answer. Next, we have to find the slope of the transverse common tangents. We know the value of theta and alpha. So the slope of transverse common tangents will be tan theta and minus tan alpha. Now the value of tan theta is 3 by 4 and the value of minus tan alpha is minus 3 by 4. So these are the slopes of the tangents that is given in option number C. So option number C is also correct. So answer of this question will be option number C and D. Next, let's discuss question number 58. Here, 3 summations are given, that is Sn, small sn and phi n. Now, let's start with phi n. Phi n is equal to, when I is equal to 1, then j will go from 1 to n, that is 1 plus 2 plus 3 up till n. And when I is 2, then again it will be 1 plus 2 plus up till n and so on. So this is equal to summation of 1 plus 2 plus up to n whole square, right? So it will directly be equal to n into n plus 1 by 2 whole square. Next, let's find the value of small sn, that is equal to, if I put I equal to 1, then j will go from 2, 3 and up till n. Similarly, if I put I equal to 2, then j will go from 3 plus 4 and so on up till n. So this can be written equal to n into n plus 1 by 2 whole square minus, from here we will subtract 1 square plus 2 square plus 3 square and so on, that is n into n plus 1 into 2n plus 1 upon 6 whole divided by 2. Is that clear? Right. Now, next is capital Sn, that will be equal to, when I put I equal to 1, then it will be 1 plus 2 plus 3 up till n, plus when I put I equal to 2, then it will go from 2 plus 3 plus 4 and so on, right? Similarly, when we put n equal to 3, it will go from 3 plus 4 and so on. So this can be written equal to n into n plus 1 by 2 whole square plus n into n plus 1 into 2n plus 1 upon 6 whole divided by 2. So this is the value of capital Sn. Now let's firstly solve option number A, which says that limit n tending to infinity small sn upon phi n is. Now small sn have two terms, that is this and this one. So when first term is divided by phi n, then we will get 1 by 2, minus when second term is divided by phi n, then in the denominator we will get an extra term of n. So as n is tending to infinity, that term will be equal to 0. So directly we can say that the value of the limit required in option A is equal to 1 by 2. So option number A is incorrect. Next, in option number B, we have to find the number of prime factors of S7. Now, to find the value of S7, let us put the value of n equal to 7 in equation 1. So S7 will be equal to 7 into 8 by 2, that is 4 whole square, minus 7 into 8 into 15 upon 6, and in the denominator we have 2. So solving this, we will get it equal to 2 into 7 into 23. So the number of prime factors are 3. So option number B is the correct answer. Similarly, in option number C, we have to find the number of prime factors of S10 minus S10. Now, when we subtract small sn from capital Sn, then first term will directly get cancelled and we will get n into n plus 1 into 2n plus 1 upon 6. So, putting value of n, we will get n into 11 into 21 upon 6, that is equal to 5 into 11 into 7. So, we have 3 prime factors again. So, option number C is also correct. Now, option number D says that 24 times phi n minus Sn is always divisible by 3n plus 1. Now, the value of phi n minus Sn, this will be equal to n into n plus 1 by 2 whole square into 1 by 2 and plus 1 by 2 into n into n plus 1 into 2n plus 1 upon 6. That is, in the denominator we will have 12 and here we have 2n plus 1 also. So solving this, we will get it equal to 1 by 24 n plus 1 into 3n plus 1 into n plus 2. So we can see that 24 times this value is always divisible by 3n plus 1. So this option is also correct. So we can say that B, C, D are the correct options of this question.